Welcome back to our analysis tutorial series. In this video, I'm going to take you through one of the most powerful and generally useful features of Nanolyzer, which is the data management and database management package. Once you've completed an analysis, as you saw in the previous video, we now have all of this metadata accessible to us about the event. We have dwell time, blockage levels, maximum blockages, number of levels, all kinds of things. And we can now use those to segment our data set into interesting subpopulations. Often when we're doing data analysis, we don't need the entire data set. We're only interested in, say, the events that are folded or the events that have a particular structure to them or a particular feature to them that we're actually looking for in our experiment. And this is a way to do that. So go to Data, Data Manager, and you'll see this window pop up. And this is an interface that lets us interact with the data set we just analyzed as though it were an SQL database. In fact, it is an SQL database. And so the base operation is filtering, new filter. And there's a couple different ways to do this, and it's a lot of information up front. And I'm just going to show you the most basic filtering operations in this video, and we'll get more and more advanced in future videos. But for now, the idea is that for any metric, any of the metadata metrics we have, dwell time, blockage, whatever, you can filter the database to select on some feature of that. So for example, if I want to just look at events that are longer than 50 microseconds in length, we can do that. So let's start with that. We're going to start by naming an operation. I'm going to call it long events. Don't need that just yet. And we're going to use the dwell time as our filter feature. We're going to pick the binary operation greater than or equal to, for example, and we're going to say 100 because we're in units of microseconds. So this is an operation that will create a filter that will select all of the events that are longer than 100 microseconds. We're using the events table, and we'll discuss a little bit about the difference between these in a moment. And we hit add operation. And you can see right away we've created this operation here with the label long events. And if you're familiar with SQL syntax, you might notice that this is a fragment of an SQL query. Now, if we want to make a subset of our events that satisfies this filter, we go down to operation 3 here. We pick our long events root operation, and you'll see that it will construct a complete SQL query that we can then apply to our data set. We're going to apply this to our full data set. We're going to tick auto update plot, and I'll show you what that does in a second. And we're going to give a name to our subset, long. Now, if I hit filter and make subset, let me just move this aside so you can see the effect here. I hit filter and make subset, and this plot will update itself with all of the events that satisfy that criterion. And you can see that in this case, it's actually most of the events. And this will be a little bit more obvious if we now plot dwell time, let's say, versus max blockage as before, and update the plot. You can now see that in blue, we have the full data set. In orange, we have just long events, and they're almost perfectly overlapping. So now let's say we want to select just the long events, 100 microsecond events, that also contain at least one folded level. Right? And there's a whole bunch of different ways we could do that. For example, the maximum blockage could be used to distinguish whether an event has a folded level in it, because the max blockage around the 2,500 peak point mark here corresponds to folded level. We could also use the number of levels. If you recall correctly, with baseline blockages and baseline minimum is 3, so a folded event would have at least 4 levels in it. So we can construct a filter on the number of levels or max blockage. But let's start with max blockage right now, because some folded events have only the folded event in it, and we want to capture, in this example, all of the folded events, regardless of whether it's a complete fold or just a partial fold. We're going to call this folded. This is going to be our operation. We're going to say maximum blockage greater than or equal again, and we'll just select a number that's kind of in the middle. We'll say 2,000 picoamps. Add operation. Now, if I were to create a subset that just had folded, for example, and I'll do that right now, folded events, we now see the third subset, which is now in green, pop up here. And again, you can see it's most of them. Now, the fact that we're still seeing events pop up down here just indicates that some of these events are mixed events that have a fold and an unfolded level. But we can also do something, which is to combine them. We can mix these things. And we do that by creating SQL queries that involve mixing these fragments. So instead of, now we're going to say mixed. So this is long and folded events. We can say, now in our dropdown here, you can actually see that our SQL filter fragments are available as operations here. So we can say long events and folded events. Add operation. And now we have, again, an SQL query fragment that mixes these two things. We can say mixed. It's long and folded events, and we can create another subset. And now we have in red here just the events that are both longer than 100 microseconds and contain a folded event. And we can actually, because we probably don't want to see all of these, let's say we just want the last subset here, we can go to full data set and just turn off the plot. Long events, turn it off. Folded events, turn it off. And now we just have plotting here the long and folded events. So let's compare the full data set to the long and folded events. And so this is kind of the essence of the most basic kind of filtering you can do with Nanolyzer. You can pick any of these metadata columns here. You can apply an operation, and you can either type in a number in the numerical case, or you can compare these things directly. If you want, when you're building things, you can also use the negation operator to select everything except things that match your filter, for example. And in terms of the just simple query building, this is the essence of how most of the post-processing is going to be done using Nanolyzer. Usually there are multiple ways to get at the same information. So for example, we got at the subset of events that were longer than 100 microseconds and folded by looking at filters on the max blockage and their duration. But we can also define filters another way. So we can look at, let's say, multi-level events. Here we can look at the number of levels greater than or equal 4 in this case. And now we can say, instead of looking at the max blockage as a way to select whether an event has a fold in it or not, we can look at, we can use the number of levels. And so we can create another operation. And you can see now that we've defined this mix to, need the underscore there. Can't use spaces in these labels for the moment. And then we can select it here and create our data set. And for the most part, with a couple of exceptions, these are essentially the same information. So in a future video, I'll get into the more complicated operations where we can define not just operations on a single table, selecting events on one of these, but we can actually do filtering that involves both sublevel information and single entry metadata information. And together, these create a very, very powerful tool for segmenting data sets into interesting subsets to speed up analysis. Once you're satisfied that your subsets are set up as you like, you've built a subset of your data set that contains only the events that you actually want to be looking at, you can save them. So you can save a subset here, which will prompt you to select the subset you want to save it, and it will prompt you to give it a folder to store this in. I'm not going to do it just yet. You can also load a subset that you've previously saved, and you can select this, which will pop up a list of the filters that have been applied to that subset in order, so that you can relatively easily go through and check all of this out. In addition, while building these filters can be a pain the first time, just like the analysis setup, you really only have to do this once because you can save these things. So you can save a filter, which saves a special file that encodes the filters you've used here, and then you can later go back and load them through this open filter button here, so that you only really have to construct these filters once. And once you've set these up, these numbers are easily interchangeable. So let's say we decide that our long events definition needs to change. Well, we can go to modify expression here, which will pop up this window. We can change this to, let's say, let's make it a little longer. Let's say 150. And you can see actually that not only has this number changed here, but it's also changed everywhere else that that filter is actually used, right? And so now we can go back and we can redefine a data set where we're now using this 150 as our cutoff. We tick make data set, and you can see now that this has been applied, and you can see the cutoff at 150 microseconds. And so once you've created these filters once, you can reload them easily. And you can change them as you need to apply to the new data set without having to rebuild everything from scratch. So we're going to pause here, and in the next video, I'm going to take you through clustering and using some of the machine learning tools available in Nanolyzer to automatically label subsets and label events. And then we'll come back and we'll show you some more advanced filtering operations.